Welcome in the arena. My name's Allyson Klein. This is a data insights episode, which means I'm here with Jeniece Wnorowski from Solidigm. Hey, Jeniece, how are you doing?
Hi, Allison. I'm great. How are you?
I'm doing great. It's the dog days of summer, Jeniece, and we're kicking off a fantastic episode about the future of compute. Tell me who you brought with you.
It's hot, but so is our topic. Today we have Ilkhom Sidikov from IONET, and we're going to talk all things AI infrastructure and Neoclouds. So welcome to the program, Ilkhom.
Yeah, hello guys. I'm really glad to be here and thanks for the invitation.
Ilkhom, tell me a little bit about IONET and what your role is as a software engineer at the company.
Yeah, I joined INET in early 2024. Like it was all getting started. And as we know, it's a Neocloud right now. It started in the age of Web3 and AI. So we make decentralized GPU network usable for AI startups and developers. So yeah, it's everything related to GPUs and AI application use case. When I joined, I mostly worked on the network infrastructure side. But since 2025, my main project was IO Intelligence. Is the vector where we develop applications for AI startups like model training, like model inference, video and image generation. And one of our recent success was getting listed on OpenRouter. OpenRouter is LLM gateway that all we know. And we do right now from 2 to 5 billion tokens a day, hosting open source models on our GPU network.
Awesome. I mean, with today's models, right, serving billions of tokens per day, what's running inference at scale kind of taught you?
Oh man, that's in early 2024, like 2023, like even million token was like a real huge thing. But as you know, like every year, like scale is skyrocketing, and today we talk about billion tokens a day, and I think OpenRouter does trillions of tokens a week. The scale is expanding a lot, and the bottleneck that we have on like hardware and on the GPUs is really coming into the play. So at this scale, as an engineer, I learned a lot about trade-offs, right? Sometimes you want the model to be always right and always good quality, but um, you can lose on the throughput or on the latency. So running models at scale taught me to handle different trade-offs, right? For example, for OpenRouter, it's very important so that you have low latency and good throughput, but you can run quantized models. For example, you can quantize the model up to like FP8 or int4, and it really speeds up. So, but the quality degradation is not much. So for some of the daily use cases, it's not even noticeable. So at scale, we are like getting challenges of trade-offs every day, like what we can optimize, what we can improve, and what we can like give up in order to gain something better. Yeah.
Now, Neoclouds really sit at the forefront of AI infrastructure deployments and really understanding AI workloads within a context of large scale. How do you see the traditional cloud models straining hardest to support AI workloads within these types of environments?
Um. Oh, this like if you talk about hyperscalers like AWS and others, as we know, like making an AI product or AI startup has become very easy now. Even if you don't have an engineering background, you can make your product, like make your agent and run it. So with less knowledge or even less budget, it's really hard to talk to such hyperscalers because they demand like from 1 to 3 year contract usually, and you will be locked in. So this is the main problem, I guess, so that like hyperscalers will be very safe in order to make the contract for themselves, like so that they don't lose money, right? And for small AI startups and like engineers, it's really hard. And again, fees as well. So they need to make money. So like they build really big the data centers, but the GPUs they're putting in, for example, like H100s, H200s, they might get outdated after a year or two, right? So if you get a contract of like 4090s for 3 years, I think after a year you will not be using them that much because GPU development and like new GPU architectures and even inference hardware architecture is changing a lot. So this is one of the problems on hyperscalers, that you'll be locked in for a longer period of time. The second is, of course, the economics, that it's a lot expensive. And yeah, I guess the third one of the advantages of them is that like for some startups, they're giving grants. So for some chunks of your company, you can get a AI grant of like hyperscalers. But again, you will be locked in into their ecosystem. For example, you will be forced to use Azure infrastructure for your backend application as well, and others. So it's really really hard for AI startups. So that's why I think Neocloud is a really good option for new AI startups, where it will be like more flexible. Like we can negotiate. You can
Mhm.
also use as a pay as you go. For example, we support pay as you go for GPU renting as well as for LM inference, right? And it's very flexible for like smaller teams.
So Ilkhom, walk us through what happens under the hood when a customer spins an AI-ready cluster, and what makes possible at a fraction of hyperscaler pricing.
Mhm. I think the first thing, as I told, is the way how we can negotiate of the timing. For example, you can create a cluster on pay as you go, and you can use it for like 10 hours, 12 hours. So
Mhm.
with this logic, we can, for example, give you the AI cluster at a fraction of the price for a day, and once you have used it, and we can again plug it in into LM inference side, so we never lose money on the idle GPUs. So we bring the down of like keeping the GPU on our hand, because while it's idle, there is a meme like idle GPU as well as like fully utilized GPU costs the same. So you never want to keep GPU idle. So that's why we have an infrastructure for LM inference. And when there is no customer, like we can put it in the LM inference. And when there is a customer coming up at a fraction of the price of the hyperscalers, we can give it. So this explains why hyperscalers make the GPU price so much expensive, because they need to cover their costs, and they don't sell like such amount of tokens like in a dynamic change, right? For example, you can change in a day, the cluster runs on a LM inference side, and tomorrow it can be ready for you to train models on our cloud.
When you think about enterprise teams, a lot of them bring healthy skepticism to decentralized compute. Some of the concerns are reliability, security, consistent performance. How do you see that evolving with AI, and how do you work with enterprises to meet their workloads on your infrastructure?
Mhm. So when we started in 2024, we were open for anyone who has a GPU and come in as a
Mhm.
player into our network. And we have seen a lot of fraud. So people would be cheating that they have 4090, but they will change the metadata of the GPU, change some software, and make some hacks. And they pretend that they have H100, right? Like 10 times expensive GPUs. And but on the speed side, we can really tell that they are line. So over a period of this time, we have built a lot of software on top of like identifying GPU quality. So every hour we run proof of work on the GPUs that we host. So we always check the hash rate and make sure that if it's pretending to be H100, we really check that it performs as H100 based on our benchmarks. So these benchmarks are real time and like updated every day, every hour. And we will be sure that no one is like pretending to have like a higher grade hardware that they're selling. This is the first thing. On the second side, like about the network, about the safety, we also use VPNs like to connect different nodes from different places. and inside the VPN, like it will be easy to transfer data as well as like work with like model training, right? And probably on the security side, some enterprise clients would ask, for example, confidential inference. So we are developing and releasing new features. For example, on confidential inference side, we have released a new router where like you can use dedicated AI cluster through our API, and you can prove that every inference that you are making, like every token generation, is done in a confidential environment, starting from GPU level to the like to gateways to the like backend applications, etc. So we are working hard so that we are meeting those requirements from like enterprise clients that they are asking.
What about inference though? Like specifically, what are the biggest levers for cost cutting latency at scale?
So this LM inference is still considered as a new space. For example, like new open source models were becoming very popular in the recent like 2-3 years. So we have tested really like different bunch of inference engines like SGLang, VLLM, and other open source frameworks. If you're just starting and if you deploy a model on like open source model and you check your results, you say that everyone who's selling API tokens, like LM tokens, they're losing money, like they're burning cash because the math doesn't make sense, right? So with H100, you can generate, let's say, 1 billion tokens, but the price of 1 billion tokens doesn't make like even half of the GPU cost. So in this place, you really need to focus on optimization and like cost cutting. The main thing is, again, as I said, like everything around GPU. Like on the model, you would be focusing on quantization. Of course, you would need cache. Like even on token generation, there is a cache technology, KV cache. So with KV cache, you can speed up your like throughput 2 times more even if it's configured properly. So quantization, KV caching, and batch inference. So using really low level technology, like low level techniques, you can bring down of dollar amount of generating, let's say 1 million tokens to the minimum. At this level, you can set the price of the like market and like make profit. So without this, like if you just deploy raw model and you just deploy using like default parameters, it will be really hard to make even break even on some GPU hardware. So we have really focused on optimizations on the hardware side. Like yeah, again, as I said, like cache and
Hmm.
other quantization sites. Yeah.
Now, you've described your distributed computing model where you've got, a broad network across the globe of GPU clusters that are connected together. Can you talk a little bit about how you manage that and how you route inference across it?
hmm for inference, we always try to create a cluster of the GPUs that are close to each other, and we have our internal, and it's also available for other users called infrastructure called container as a service. So container as a service can like connect every VM with GPU to its network using open source frameworks. Again, I'm not sure if I can tell the details, but in this infrastructure, we collect and connect all the players. And when it comes to creating a cluster, for example, for hosting models, usually even the big models like GLM 5.2 that has been released recently, you just need one machine but with 8 cards. So usually our containers and LLM replicas run on the single machine. It's very rare that you connect different machines to talk each other because um, simply like big models doesn't fit on consumer grade GPUs. That's why big models we deploy on like Hopper or like Blackwell GPU hardware, and those come with like data center setup. So it's much easier for us. If you talk about lower grade, you can always combine those consumer grade 4090s, for example, from US, from Japan, and from India, and you connect them through the VPN, and you spin up a container like that that you can use as a one cluster. Yeah.
The
Nice.
industry is kind of moving from chatbots. I mean, it has been moving from chatbots to agent systems and running longer, branch unpredictably and hammer infrastructure in new ways. But what do they demand from compute and data that a single model inference never did?
Yeah, when the agents got really popular with OpenClaw and others, the main topic was how LLMs would evolve. Recently, Anthropic CEO even said that nothing is stopping us to make 1 million tokens of context size for the model. And this context size of the model is even more than the human can absorb information through his or her lifetime. So when like agents got real popular, LM started increasing their context windows up to like a million tokens right now we see. And this really ruled out RAG systems out of play. For example, in 2022, 2023, RAG systems were really popular. Like people were creating vector databases and using for agents and using for chatbots. But these agents, LLM models with longer context size, really helping them to use like needed information in their context. And the second thing of development of MCPs and skills and others gave agents a really cool superpower. For example, they no longer need a database of prices of the stocks, right? They have a skill or they have an MCP server. They can just call it in real time as just as a human. So agents got really more closer to human being like experience, how they talk
Mm-hmm.
and how they utilize some of the resources. So I think that's the one thing that differs and improved from chatbots. That it's no longer about just LLM and inference. It's more about uh, using real-time data, using MCPs, using skills, and having longer context that it um, maintains the memory. Yeah.
I think that I'm a huge fan of distributed computing, and I think you guys are, cutting new ground in this space. I love what you're doing. If you look 5 years ahead, how do you see distributed computing taking a portion of traditional cloud? And do you think that this is the new computing model for us all moving forward?
Um. Yeah. It's very ambitious to say that it will win against hyperscalers. Uh, because still the government and like big players who have cash and ability to make big contracts, they sometimes choose hyperscalers because of the reputation, maybe because of like some of the ideas that they're more stable and etc. But if you talk about human like individuals who use AI every day, for
Hmm.
example, you can use any product right now which has AI based model under the hood, and more likely it's going and making inference on some of the Neoclouds through OpenRouter, let's say, because it's economically cheaper. So on the individual side, like to day-to-day use cases, I think and I believe that Neocloud and decentralized network can win over hyperscalers because it's economically cheaper. And the cool thing of running a LAMP inference is it's stateless, and because of this you can utilize always economically cheaper provider. And in most of the cases cheap providers are coming from decentralized network because it's democratized and it's optimized so that it will be cheaper for the user. Yeah.
Wow.
It's fascinating. This has been an amazing conversation. I do have more questions, but I know we're out of time, and I know our listeners would want to learn more as well. Where should they go to get more information from you?
I usually share some of the insights from my day-to-day work on LinkedIn. So you can go and connect with me on LinkedIn. And yeah, I share some blog on my Telegram channel. So if you guys are on Telegram, yeah, connect on Telegram as well. Yeah, and if anyone has questions or they have some ideas about decentralized network or GPUs or LM inference, just say hi on LinkedIn. You will get in touch, and yeah, we can discuss cool stuff.
Well, I will certainly be following you and the team to see how you progress. Thank you so much for spending time with us today. And Jeniece, yet another fascinating conversation. The world of distributed computing is taking off, and we're here at the front row.
Yeah,
Agreed.
thanks for having me, guys.